Good morning, everyone. Thank you for joining us. I'm Steve,
I'm Scott.
and together we are Backyard Musings, broadcasting Apple Valley, California.
Science and Technology Channel.
Scott is the expert. I'm just color commentary.
Expert of nothing.
Okay, I'm the expert. Scott is color commentary.
I'm colorblind. I don't know about color commentary, but
Right, I'm not.
we'll go.
Okay, we'll go with that. We'll leave it there. NASA's Curiosity Rover has unearthed the largest organic molecules ever detected on Mars, possible fragments of fatty acids, hinting at the tantalizing possibility that prebiotic chemistry on the red planet may have been more advanced than previously thought. Found in a sample from Gale crater's Yellowknife Bay, that's not something near San Francisco. That's on Mars. I didn't know there were bays on Mars.
Gale crater.
Okay.
Yeah.
These molecules suggest Mars once hosted conditions suitable for complex chemical evolution, possibly even life. Although the origin of the molecules remains uncertain, their preservation and size boost hopes for finding biosignatures in future missions, especially with plans to bring Martian samples back to Earth. This was published on March 24, 2025, in the Proceedings of the National Academy of Sciences. Would you like to know more?
So, do you believe that there could have been life on Mars before?
Well,
I mean,
what do you define as life? Like amoebas?
Yeah. No, like humans.
Oh, I don't know.
You don't think that could have been a world like ours at one time, and then they just became so evil that it was like, okay, you're done?
I don't know. I'd have to look into it, like temperature and that. I know it's kind of in the Goldilocks.
Maybe how it is now, but but maybe millions and millions of years ago there was life there.
Maybe, I don't know. Maybe
and
you put me on the spot here in front of our followers.
Well, I'm just asking your opinion.
I haven't researched.
I'm not holding you to it.
So. What do you think?
I think there could have been. I think there could have been life on any of these other planets. Maybe at one time these planets were aligned differently, and there was like a cosmic shift or something. And
gravity.
Yeah. So
those things happen.
Yeah. Why would we be the only planet in our solar system that has life? I just don't. Yeah. I don't know. Anyway.
Well, what I do know is there's a Goldilocks zone from the sun. And if a planet's in that zone, then it's ripe for...
It's habitable
for human life and animal life.
Right.
Out of that zone, or too close to the sun is too hot, too far, it's too cold.
But you could say that for even our own planet, right? I mean, we live here, but people that live down in the equator, within the equator, it's hot, right?
Yeah,
all
the
hot. Time.
Yeah, I've been down around there.
Yeah, it's hot all the time. So it's like going from here to Palm Springs in the summertime.
Snow. They don't see snow.
Right.
Yeah.
Okay, back on the subject. NASA's Curiosity Rover has detected the largest organic compounds ever found on Mars. The discovery, published on March 24th in the Proceedings of the National Academy of Sciences, suggests that prebiotic chemistry, the kind of chemistry that can lead to life, may have progressed further on Mars than previously thought. Okay. Researchers reanalyzed a previously collected rock sample by using Curiosity's onboard chemistry lab, known as the Sample Analysis at Mars, or SAM, instrument. They identified 3 molecules: decane, undecane, and dodecane, which contain 10, 11, and 12 carbon atoms, respectively.
I don't even know what that. I've never heard of that.
I don't either.
They make this up? Have you ever heard of decane, dodecane, or undecane?
Yeah.
I don't know.
Let us know.
Yeah.
These molecules are... Oh, I'm sorry. That's yours.
Yeah, so I was going to say, this is why we need boots on the ground. We need boots on the ground to do the analysis, ship it back in a little probe or whatever, ship it back to Earth and catch it with a little net and get it down here. You know what I'm saying?
We need to do that, but we need to do that, not to put politics into this, but we need to do that when there's somebody in charge that's going to go get these people if a problem arises, rather than leave them stranded for almost a year. So anyway,
I agree with you on that.
Back to the subject.
Yeah. These molecules are believed to be fragments of fatty acids. These are organic compounds that, on Earth, are key ingredients in the formation of life. Fatty acids are commonly produced by living organisms to build cell membranes and carry out other functions. However, they can also form through non-biological processes, such as chemical reactions between water and minerals in environments like hydrothermal vents.
Okay. Although the origin of the molecules remains uncertain, their presence alone is a significant and exciting find for the Curiosity science team for a couple of reasons. Curiosity scientists had previously discovered small, simple organic molecules on Mars, but finding these larger compounds provides the first evidence that organic chemistry advanced towards the kind of complexity required for origin of life on Mars. So, okay.
The new study also increases the chances that large organic molecules that can be made only in the presence of life, known as biosignatures, that could be feces. That's a biosignature, right?
Or leftover bone or leftover
Spit, saliva,
meat, right?
Could be preserved on Mars, allaying concerns that these compounds get destroyed after tens of millions of years of exposure to intense radiation and oxidation. Another important thing that we need a firmament. You got to have a firmament too to sustain life.
Right.
This finding bodes well for plans to bring samples from Mars to Earth to analyze them with the most sophisticated instruments available here, the scientists say.
Okay, this is a quote. Our study proves that even today, by analyzing Mars samples, we could detect chemical signatures of past life, even or if it ever existed on Mars, said Caroline Fressinet, the lead study author and research scientist at the French National Center for Scientific Research in the Laboratory for Atmospheres, Observations, and Space in Guyancourt, France.
Yeah, Guyancourt, France. In 2015, Fressinet co-led a team that in the first conclusively identified Martian organic molecules in the same sample that was used for the current study. Nicknamed Cumberland, the sample has been analyzed many times with SAM using different techniques. Curiosity drilled the Cumberland sample in May 2013 from an area in Mars' Gale crater called Yellowknife Bay. Scientists were so intrigued by Yellowknife Bay, which looked like an ancient lake bed, they sent the rover there before heading in the opposite direction to its primary destination of Mount Sharp, which rises from the floor of the crater, probably rises sharply. Mount Sharp.
The detour was worth it. Cumberland turns out to be jam-packed with tantalizing chemical clues to Gale's crater's 3.7 billion year past. Yeah, that's a long time.
Yeah.
Scientists have previously found the sample to be rich in clay materials, which form in water. It has abundant sulfur, which can help preserve organic molecules. Cumberland also has lots of nitrates, which on Earth are essentials to the health of plants and animals, and methane, made with a type of carbon that on Earth is associated with biological processes. So,
yeah,
I'm telling you, man, there could have been life there at one time.
I'm starting to become a believer. Perhaps most important, scientists determined that Yellowknife Bay was indeed the site of an ancient lake, providing an environment that could concentrate organic molecules and preserve them in fine-grained sedimentary rock called mudstone. Quote, there is evidence that liquid water existed in Gale Crater for millions of years and probably much longer, which means there was enough time for life-forming chemistry to happen in these crater-like environments on Mars, said Daniel Glavin, senior scientist for sample return at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and a study co-author.
The recent organic compounds discovered was a side effect of an unrelated experiment to probe Cumberland for signs of amino acids, which are the building blocks of proteins. After heating the sample twice in Sam's oven and then measuring the mass of molecules released, the team saw no evidence of amino acids. But they noticed that the sample released same amounts of decane, undecane, and dodecane.
Because these compounds could have broken off from larger molecules during heating, scientists worked backward to figure out what structures they may have come from. They hypothesized these molecules are remnants of the fatty acids undecanoic acid, dodecanoic acid, and tridecanoic acid, respectively.
The scientists tested their prediction in the lab, mixing undecanoic acid into a Mars-like clay and conducting a SAM-like experiment. After being heated, the undecanoic acid released decane as predicted. The researchers then referenced experiments already published by other scientists to show that the undecane could have broken off from the dodecane acid and dodecane from the tridecanoic acid.
Way over my head, man.
Yeah, way too many.
Can you say everything after acid?
Vowels in that. Yeah.
The authors found an additional intriguing detail in their study related to the number of carbon atoms that make up the presumed fatty acids in the sample. The backbone of each fatty acid is a long, straight chain of 11 to 13 carbons, depending on the molecule. Notably, non-biological processes typically make shorter fatty acids with less than 12 carbons.
It's possible that the Cumberland sample has longer chain fatty acids, the scientists say, but SAM is not optimized to detect longer chains. Scientists say that ultimately there's a limit to how much they can infer from molecule hunting instruments that can be sent to Mars. Quote, we are ready to take the next big steps and bring Mars samples home to our labs to settle the debate about life on Mars, said Glavin.
Or put boots on the ground, you know what I'm saying?
Yeah, send them up there. Yeah.
Put them underground.
Even if it's in a pod, like a controlled pod that they could stay in and then just have like robotic arms that go out, but then they'd have to be able to get back. But we talked about that a few weeks, right?
You ever watch The Martian?
You mean with Damon? Matt
yeah,
Damon?
Yeah.
No.
You never watched it.
Yeah.
I think they need to go underground. They need to build like domes or something underground. That's what I think.
Yeah.
Rather than risk, the weather or whatever destroying the habitat or meteors hitting it. Go underground, man.
I mean, what if we built we've got an International Space Station. What if we made one of those that could land on the surface of Mars?
Man. Come on, man. If that could have been done, we would have done that, man. You're talking about landing this huge space station thing.
Working on that right now. So
we're trying to land like the re-entry rocket. SpaceX has just barely cracked that code.
Yeah, well, it's going to happen. I'm telling you. Probably not in my lifetime, but definitely my grandkids' lifetime. In fact, I asked them the other day. I said,
"You got cute grandkids.
Would you be willing to take a space ride to the moon or to Mars?" And a couple of them kind of hesitated.
Oh,
but I mean, if I were older, I'd probably do it, and if I were way younger, I'd do it. But too many responsibilities.
You were older, like if you were 90, because you're like 85 right
now. Yeah. If I was 90 and they let me go, 90. If I could pass the physical, I'd go. That'd be kind of cool. But I wouldn't do it right now. So
you probably get a heart attack from the G-force getting off the planet, man.
Yeah, I could.
And they just dump your body in space burial.
They can just send me down to the surface, and I can become some of those amino acids.
There you go. All right, folks. Thanks for joining us. We'll talk to you later.
Take care, everyone. Thanks. Have a good day.